Hello there everyone, a very good afternoon to you and welcome to this online CLPL session organised by Dynamic Earth, focusing on learning for sustainability in the context of oceans and climate change, made possible with support from the Scottish Power Foundation. A very warm welcome to you this afternoon. Thank you all so much for joining us. In particular, a very warm welcome to you if you also joined us for our climate change session back in February. We're delighted to welcome so many of you from across Scotland today for this session, and we hope it's going to give you lots of different ideas and experiences for how you can do learning for sustainability with marine environments in your classrooms with your learners. My name is Conor. I am the Learning and Engagement Manager here at Dynamic Earth in Edinburgh, and I'm delighted to say that I'm going to introduce you to a wonderful team that are joining us today as our starting points. So we'll be kicking off shortly with Nadia Jogee from the University of Edinburgh, who is a marine specialist, joining us all the way today from Lanzarote. So Nadia, thank you very much for giving us your time. And we've also got members of the Dynamic Earth Learning and Engagement team ready to engage you as well. We've got Blair Watson and Katrina McPherson, who are both science communication experts and marine specialists as well. So thank you very much to both of them for giving us their time this afternoon. We also have Lauren Hockenhill, our fantastic online learning coordinator, keeping us to time and making sure all of the tech works as well. Before we get started, a couple of bits of housekeeping. We're recording this session today to share it with other learners and other teachers who weren't able to join us today. And you'll be able to join in with the chat function whilst the session is active today as well. So if you've got any questions, fire them in there and we'll do our best to answer them for you. Before we dive in, and I promise you there'll be more marine puns throughout the presentation, I've just got a few moments to tell you about Dynamic Earth, who we are and what we do. So we are Edinburgh's Science and Discovery Centre dedicated to earth and environmental sciences, and our mission is to empower everyone with understanding and empathy for the earth, to be the generation that creates a positive future for us and our planet. As you know, we do that in lots of different ways, including our immersing and exciting exhibition, which right now is currently getting a major refurbishment on its marine galleries. My colleague Blair will tell you more about that in a wee bit as well. We also have a brand new planetarium, and we are the only planetarium, to the best of my knowledge in the world, that takes you to ocean depths as well as outer space. We've recently launched a brand new underwater show focusing on marine environments, which we'll tell you a bit more about in the session as well. And we also have our dedicated schools programs. And I'm really pleased to share with you today that for our next academic year, we'll also have so many more marine experiences for your pupils as part of our school workshop program. But it's not just about those indoor experiences. We also have a whole host of content available as part of Dynamic Earth Online, including ready-to-go activities and experiences for you in your classroom. Katrina and my colleagues will tell you a bit more about those. And your learning can continue from on the back of this session today as well. We've also got a whole host of free, flexible CLPL modules available online, focusing on learning for sustainability and the UN Sustainable Development Goals. That's enough from me. I hope you enjoyed the session this afternoon. And right now, I'm delighted to hand you over to Nadia. Nadia, over to you.
Hi everyone, really nice to meet you. Bear with me just one moment whilst I share my screen. But really nice to meet you all. Thank you so much to the team at Dynamic Earth for inviting me along to the CLPL session. It's really nice to get the opportunity to speak to you all. And I'm going to speak to you today about corals and coastal communities, which is my area of expertise, and touching mainly on the ecosystem services that they provide and a little bit about my own research, but just as a bit of a plug there as well. Okay, so a little bit about me first of all. So many moons ago when I was, in college, I thought I was going to be the next Vivienne Westwood and I wanted to go to do fashion, but I very quickly decided that actually it was just a hobby and it wasn't really for me. So I went on to do zoology at the University of Manchester when I graduated in 2014. After that, I've done a few different things. I've worked professionally as an aquarist, which is just a fancy word for a fish keeper, essentially. And I've done that at places like Chester Zoo and London Zoo, which really brought me into contact with, marine species, which was a really great opportunity. But now I'm doing my PhD at the University of Edinburgh, and that's what I'm going to talk to you about today. So, here we go. So now is a really exciting time to be a marine researcher. We are in the UN Decade of Ocean Science, and I think when we think about our world, we often think of this kind of map here, where we've got the land as the focus of the picture, and that's because we're land-based mammals, and that's understandable that that's the bit that we would focus on. But this image is one that I really like, and this is a map of the world where the ocean has taken center stage. And what you can see here, these arrows, is the main ocean currents. So you can see that not only is it one ocean, but it's a really connected ocean as well. So things that happen up here in the Arctic very much do influence things that happen all the way at the opposite end of the globe in the Antarctic. I like to think of this as the fisheye view of the world. So I'm going to play a video now, and this is about the UN Decade of Ocean Science, and it explains the decade much better than I can. So it's just a short video. So I just think that really nicely highlights that not only is the ocean an environmental resource and it can help tackle some of the world's biggest environmental issues, but it also tackles economic issues such as poverty and unemployment, and also social issues as well. So it's a really exciting time, as I say, and it's nice that the UN have recognized the importance of a healthier ocean. So, as I say, there's plenty of habitats that can be found within the ocean, and I'm sure Blair and Katrina will talk about some more local ones when we pass on to them. But I'm going to talk to you today about tropical coral reefs, which is what my research is interested in. So 500 million people worldwide rely directly on coral reefs, and that number is likely to rise with human population increasing as well. And it adds a huge amount of money to local economies. In the Coral Triangle alone, which is this area down here in this map, from the Philippines round to Singapore and down through the Oceanic Islands, down through the Solomon Islands, it's expected that within the 13 years between 2017 and 2030, it's going to add about 36.7 billion to the local economy. So coral reefs are hugely important to local communities. But how does it generate all that income? So ecosystem services is a term that we use in ecology that relates to the direct and indirect contributions that ecosystems provide for human well-being and the quality of life. And this image here, this cartoon that I've put together, helps to represent some of these. And so we'll go through all these one by one. But we've got coastal protection, biodiversity, tourism, medicine, and fishing. So what do we mean by coastal protection? So a healthy reef builds up over many years, over thousands of years, and corals themselves are an animal that are made from a colonial animal of lots of polyps that produce this calcium carbonate skeleton. So it's why sometimes you might think of them as looking quite like rocks. And when they die, they crush down and they form compacted rocks. So this area here, this dark blue area, is built up dead coral over time, and this creates this reef structure. And then you have the living reef on the outer edge of this. So when the reef is healthy, you get waves and storms out to sea that come in, hit this huge structure, and this wave energy is dissipated. And so beyond the reef, you have this nice lagoon area where you can do things like diving and sailing and fishing and all the things that we enjoy doing, all those things that provide economic benefits. When the reef is degraded, so when this living layer is damaged, the height of the reef is reduced, and so you don't get this effect of coastal protection, and instead what you get is the waves actually making it all the way into the coast, and this erodes away island formations and the beaches that we like to lay on. There's another habitat here as well that's depicted, which is the mangrove, which is a very interconnected habitat with a coral reef, but I'm not going to touch more on that there. These slides will be available to you afterwards, and I'm not going to play it now. It's about 5 minutes long, but this video here, produced by Greenpeace, is an interesting video about how the coral reefs of Sri Lanka actually protected areas of the country from the Boxing Day tsunami. So that's an interesting little watch as well. Okay, tourism. So, we all think of beautiful tropical reefs because they're stunning, they're highly biodiverse. And ecotourism is a huge sector. It's not just people who enjoy going diving and snorkeling. It's also people who enjoy going, recreational fishing, laying on the beach, soaking up the sun, all of these things that we all love to do on holiday. A lot of them wouldn't exist if it wasn't for the coral reefs themselves. And it can add a huge amount of money. So $19 billion per year is added to the global economy via tourism alone on coral reefs. And also, like, dive operators are in a unique position where they can educate tourists as well about the importance of natural habitats such as coral reefs. Medicines. So this is something that people don't often think about, but in actual fact, coral reefs can be thought of as our own natural pharmacy. Coral reefs are hugely biodiverse. They have 25% of all known marine life in an area that covers just 0.1% of the ocean floor. So a huge concentration of different species of animals. And because of that, they've developed some very interesting mechanisms for to compete with one another. So in this image here, you can see corals that are living side by side with one another in competition for space. Now, corals don't have arms, legs, or teeth like you and I. They can't punch, bite, and scratch one another. So instead, what they've developed is compounds that basically attack one another like chemical warfare. So they can sting one another and they can release toxins that affect one another. Now, clever scientists out there have discovered that actually some of these compounds can be derived from these organisms and actually used in medicines. So as an example here, this is a coral called lobophyton. It's a soft coral. And a compound from this species has actually been used in the treatment of HIV. It helps to reduce the viral load. Other compounds from coral reef organisms have also been used in things like drugs for Alzheimer's and even COVID as well. And so if we were to lose these natural pharmacies without, before we can even discover these diseases, these medicines, it would be a real shame and a real loss to human health and well-being. Okay, so fishing is probably quite an obvious one that we think about. There's beautiful fish that are used in commercially for things like the aquarium industry, but also food. Recreation and subsistence fisheries, as well as commercial fisheries in these regions, is crucially important, not just socially, but culturally as well. Many small island nations in the Pacific, especially, their identity, their cultural identity, is highly related to the fact that they are island nation people, and fishing is a huge part of their culture. Coral reef fishes have also been shown to be much more nutritious for things like zinc. It's a vital mineral that we need. And fish have been shown to be more nutritious for those sorts of minerals than things like chicken and pork. So for a lot of people that are relying on food, fishing is a huge part of that. So that's another way that they can bring in resources. Now, there was a sneaky one on that cartoon that I showed you at the start. There was the island actually itself. So when we think about these beautiful tropical coral reef islands that we all like to visit, a lot of them wouldn't even exist if it wasn't for the coral reef. So this image here on the left depicts over time how islands are formed. So millennia ago, you'll have a volcano that erupts and forms this island out in the ocean. A reef then starts to grow around this, creating a fringing reef. Over millennia, this island will start to subside into the ocean, leaving what is left behind what we know as a barrier reef. So you can see you have this barrier reef that grows up with this nice lagoon, which is the area that we all like to sort of snorkel and dive in, and where it's nice and calm water. And eventually, over time, this island will completely sink below the level of the sea, and we're left with what we call an atoll. Now, an atoll looks like this, and over time, the breaking down of coral through erosion. Oh, sorry, skipped on a bit there, Baxon. The breaking down of coral over time creates that nice white sand that we think of when we think of the tropics. Another thing that creates nice white sand that we think of in the tropics is also parrotfish poop. So parrotfish have these tough jaws that they munch on corals. They eat the tissue of the coral and the algae that live inside the coral, and they poop out the skeleton. So next time you lay it on a nice white beach, just remember that. Some of that will be parrotfish poop. And some islands, like this image here of the Maldives, the whole island nation of the Maldives exists because of these atolls that have built up over time, and they've built their settlements here. So when we're thinking about climate change and when we're thinking about sea level rise, some of these islands, the maximum level above sea level is like 3 meters. And so when we think about sea level rise and things, a lot of these nations aren't just, climate change isn't just an abstract concept to them. It really is them fighting for their survival. So I think that's always important that we remember that. Now, finally, on that list of ecosystem services, there's biodiversity, which might be a little bit more of a sort of philosophical one. If I haven't convinced you already of the importance of coral reefs, maybe this one will convince you. But for you and I to be sat here this evening, watching this talk and me talking to you, we didn't just have to get up this morning, have a coffee and stay alert long enough to be here. We also had to have, our parents had to meet, fall in love, have a baby. We had to survive to adulthood. And if you go back through not just our ancestral lineage through our grandparents, but back through our evolutionary history of 3.5 billion years, from the very first single cell and the first organisms that evolved, every single one of them had to be attractive enough to find a mate successfully, raise those offspring to adulthood. They had to do the same for us to be sat here. But that's exactly the same for the sharks that swim on the reefs, for turtles that swim around the ocean. All of these animals went through exactly the same evolutionary history as evolutionary time as we did. And I think that's something that's worth protecting, and that we can understand that these animals need protecting. And so I think that's vitally important as well. So what are some of the threats to coral reefs? Now, as I mentioned before, I'll send you these slides over. They're quite detailed, these infographics. So I won't go through them in full detail, but I think they're really interesting for you to have afterwards. And they are taken from NOAA. And so, they just nicely highlight some of the main threats to coral reefs. So climate change, I'm sure you've all heard of climate change. And some of these, I think Blair and Katrina will touch on a little bit more. But warming of the oceans is really detrimental to coral reefs. It causes thermal stress, and it causes something called coral bleaching. Now, our oceans have absorbed a lot of the excess heat that is generated by climate change. And so our oceans are warming, and we're seeing these bleaching events more often. And this is something that my research is looking at. We're also seeing sea level rise. So as I mentioned before, small island nations like the Maldives, this is a real problem for them, and it's causing things like sedimentation, which smothers the reefs as well. It blocks out a lot of light that the corals rely on for their food. And it also is causing something called ocean acidification, which is where the CO2 dissolves into the ocean and changes the pH of the water, which causes the corals to dissolve. We also have threats related to overfishing. Now, this isn't my area of expertise, but it includes things like ocean litter, so debris and nets and the traps that we use in fishing get left behind, and that's detrimental to the reefs. It also means that we're taking some of the top predators from the reef, which has a huge knock-on effect down the food chain, all the way down to the smallest of organisms. And then land-based sources of pollution. We often don't think of ourselves as being very connected to the ocean. That image that I showed at the very beginning, that map of the world, we think of the land as the main focal point of the world because that's where we live. But we often forget that we are just as connected with the ocean as we are with the land. And everything that we put on the land, whether it's fertilizers, chemicals, all these things, they run off when it rains and it gets washed into the ocean, and this can cause a lot of damage. Ooh, flicking through again. A lot of damage to the reef. What I do like about this infographic, though, especially, is that there's some tips down the side here of what we can actually do to prevent that. So I like it when there's a bit of positive action that we can actually take rather than just highlighting the doom and gloom. So there are threats to coral reefs, and we know that coral reefs are unfortunately existing in a changing ocean. There are some threats and some actions that humans have made that are unfortunately irreversible. One example of this is in the Caribbean, where over the last 40 years or so, A series of unfortunate events has led to what we call a phase shift. And this is where 40 years ago, the reef was covered in hard coral with large fish. Nowadays, there's a lot more soft coral and a lot more algae, and a lot of the larger fish have been removed. And this is through a few different things. So overfishing of the larger fish has caused that disruption of the food web. Disease of the corals, so various diseases such as coral bleaching, like I mentioned before, caused by thermal stress, but also bacterial and viral infections as well. And then also diseases of some of the herbivores on the reef that would usually keep the algae in check. So urchins, unfortunately, a lot of the population of urchins in the Caribbean died through a disease, and now the algae is outcompeting a lot of the coral. So what we can do is we can start studying these reefs where there has been damage and start thinking about, okay, so what is going to happen in other areas so we can be prepared for how corals respond to these changes. So now just moving on to a little bit about my research. So I study a type of coral called a corallith. Now a coral, as we all think about them, they are sessile organisms. So they attach as a larvae, a tiny small organism. They attach onto a rock and they grow there into this branching structure that we think of. And that doesn't move. They live there and they adapt to that specific environment, the temperature, the lighting that they experience in that one spot, and they stay there all their lives. But a corallith is actually an unattached, free-living coral. So sometimes the larvae of a coral will attach to a piece of rubble, and then tissue will grow around this piece of rubble and then continue to grow, getting bigger and bigger and bigger. And then eventually they become so big that they are unable to be moved. And my supervisor back in 2017 published a paper looking at this. So looking at this area in the Maldives where you have these rubble strewn areas, which are very natural. You often get these rubbly areas on coral reefs after storms and things. You get bits that break down. Now, this is usually way unstable for most corals to live, but coralliths do absolutely fine amongst them. And as they get larger, they eventually form these patch reefs, and they create, therefore, new habitat for other corals and for fish and for lobsters. So they actually manage to expand the range of the reef. So that's what happens on a healthy reef. But what happens on an unhealthy reef? So coralliths on disturbed reefs, I've then been looking at another area of the Maldives where we've been having bleaching events. So in these areas as I say, when things are healthy, you get lots of these branching corals that provide lots of nooks and crannies for lots of organisms. So that's why we get such high biodiversity on reefs, is that because they're branching, they're structurally complex, they provide lots of these little hidey holes for lots of fish and other inverts to live. When a bleaching event happens, so you get this rise in sea surface temperature, and this causes the corals to bleach and die, these corals will quickly break down and turn to rubble, which I've shown you already. Coralliths do very well amongst rubble. And then because of the reduced competition between organisms and because of the ability for coralliths to survive in these rubbly areas, the corallith species then manage to encrust back onto the reef and then start to expand their range. And this can be very rapid. So in 1 year, they can expand their range by over 450%, which is huge for a coral. So here we've got this massive monoculture of a species called Porites rus. Now, this might sound really good. It might sound, well, great. You know, it's better than the algae that we see in the Caribbean. You've got lots of hard coral, still lots of, is all coral good coral? Well, the problem here is that Porites rus is a much lower lying encrusting species, which actually doesn't provide all these nooks and crannies for fish like we see in a healthy reef. So I'm looking at what coralliths are doing on these unhealthy reefs, and therefore can we start to predict what might happen in other areas, and therefore can we be more prepared for what might happen? Can we start to be proactive about how we manage these areas? Now, I don't want to leave you with a lot of doom and gloom, so I wanted to leave you with a few of my favourite things that researchers are doing to look into ways of protecting coral reefs. And there is a huge amount of work all over the world. People realize how important coral reefs are, and we want to protect them. So one thing that you might hear about a lot in the news is coral nurseries and coral restoration projects. So this is where researchers take fragments of coral, so small little branches, they grow them up in nurseries and they replant them back onto the reef. And they replant them onto the, hopefully you might be able to just about work out, there's these sort of lattice type structures that are raised off the bed, which provides a lot of space and stability as well for the corals to grow. And I like this image here because they've replanted these corals in the word hope, which I think is a really nice inspirational bit of work. This image here is taken from the Caribbean, and in the Caribbean there's a disease that's killing a lot of corals, and the disease is called stony coral tissue loss disease, which is a complete mouthful. And it's a bacterial infection that once the coral is infected, the tissue dies off. So this white area here is exposed dead skeleton, and this brown area is the living tissue of the coral. Now, this white pasty thing that you can see around the edge is where the researchers have developed this putty type substance that's imbued with antibiotics that they can then pack on the coral to help kill the bacterial infection and stop the growth of that tissue loss, which I think is pretty cool. And this image here is representative of something which sounds very exciting called supercorals. So as I mentioned before, corals bleach, but not all corals bleach. The reason that some bleach and others don't is because the algae that live within coral tissues that photosynthesize and produce a lot of the food for the coral, some of these algae are really susceptible to high temperatures. And when it gets too warm, the algae gets kicked out of the coral because they start damaging the coral. And that's why the coral turns white, because it's actually the algae that produces the coral's color. But some algae is more resilient to these rising temperatures. And so some corals don't bleach. Now, a lot of research is looking into what it is about some of these algae that cause bleaching and some that don't. And therefore, if we're going to do this sort of restoration, like I mentioned first on this slide, then maybe we should be replanting the corals that are more resilient, these supercorals, and rather than the ones that are going to be susceptible to bleaching events again. This picture here, even though it's not actually of a coral reef, it's actually of a kelp forest, but this is just to represent marine protected areas. So this is a really widely used management tool where we protect an area from things like fishing and exploitation to allow it to recover. And there's also work now looking at flexible marine areas, so how we can sort of move them around, a bit like how we do with fields and farms. And then finally, this one here is something that we can all think about doing when we go on holiday. So actually, a lot of sunscreens are really damaging to corals. Some of the compounds that we use to protect ourselves from the sun actually damage the corals and kill them. But there is reef-safe sunscreen that you can buy. And a lot of sunscreens are now actually labelled as reef-safe if they are. So when you go on a holiday, it's just a simple thing that you can do to help protect the coral reefs. Now, I appreciate that was a whistle-stop tour of the importance of coral reefs. If you do have any questions, I think we've got a few minutes now for you to ask me any directly. But also, if not, if you don't want to ask me straight away or if something occurs to you later down the line, by all means, you can contact me here on this email. It's nadia.jogee@ed.ac.uk, or you can follow me on Twitter as well. Okay, thanks for listening. I will stop sharing my screen so I can see some of you. If you have any questions, please do ask away.
So we've got a couple of minutes of Nadia's time just now. If you do have any questions, please feel free to fire them into the chat just now. And we can see those, and we'll give Nadia a chance to respond. Nadia, that was a really great insight. Thank you so much for your time and joining us. Fantastic opportunity. Any questions, do fire them into the chat. I'm not seeing anybody typing, but thank you very much, Nadia, for sharing your contact details and your Twitter handle as well. So I'm sure people can follow you, ping some questions your way. But yeah, thank you so much, Nadia, for joining us. And what we'll do now, if there are no questions at this stage, is we'll just hand you over straight away to Blair Watson, our colleague here at Dynamic Earth.
Yeah, no worries. Thanks a lot, guys. Take care. My email's in the chat in case anybody does have any questions. But bye-bye. Thank you.
Thanks, Nadia.
Perfect. Thank you, Nadia. Hello, everyone. I hope you're having a fabby time so far. So I am going to be talking to you today. If I can find my presentation, here we go. There we are. Let's load my PowerPoint up here. Yes. So Nadia has been talking about ecosystem services, so what we get from the ocean on a global scale. So looking at these tropical areas, I'm going to be bringing this back home, and we're going to be talking about this on a local scale. And when I say local, you're beaming in from all across Scotland. So we are going to be looking at right around Scotland. So first of all, here we go. We've been looking at learning for sustainability. So by embedding learning for sustainability into the curriculum for excellence, is how we realize these sustainable development goals, in particular this 4.7. And what we do is we can use this as a starting point or a way in to explore local issues within a global context and vice versa. So that's what we're doing now. We're looking at around Scotland and what our seas do for us. First of all, I'm going to take a little bit of a trip back in time. So we're starting to look, first of all, at the culture, how we built our culture around our seas. And to do that, we're going all the way back to the Mesolithic times. So this was between 5,000 and 7,000 years ago. And you can see here in the first image on the far left here, this is a shell midden. So shell middens were basically rubbish piles. And we've excavated quite a few of these, particularly on the west coast. And what we've found here is mixed amongst these shellfish. So we can see that already way back then, we're getting a lot of our food from the sea. We were also finding human remains here, so bones of fingers and toes. So this is quite important because it shows that not only were we getting our food from the sea, but it was also playing a part in our rituals and the stories that we're telling here as well. And importantly, particularly in Oronsay, we're finding seal bones mixed in with these human bones as well. So that's showing us particularly that seals and other sea creatures were playing a part not just for food, but like I was saying, for these stories, and these stories continue on throughout history. So if we think about things like the silkies and the selkies, these tales of these water spirits, we're seeing that these stories continue on. We've also got the Fingal's Caves, this giant that lived inside there. And of course, the Corrie Vrecken, this massive whirlpool that we still have. So these stories go all the way through our timeline. Now, if we move on, you can see on the far right here that we have this little fishing village. These are scattered around our coastlines. And our fishing communities are incredibly important to us. So again, we've built our country around these fishing towns, these ancient harbours and ports. And I'd quickly like to introduce you to a concept here. This concept is the science capital. And science capital is basically a toolkit that we take through our lives of everything that we know about science, how we feel about the science, who we know that works in science. It's everything to do with this. And you can use this to your advantage here when you're speaking to your students. So 63% of Scotland is coastline. Compare this to England, that's only 31% of their coastline. So we have this massive, vast wealth and easy access to our waters, which means that the ocean probably plays quite an important part in your students' lives as well. There's very good odds of this. So by bringing in their relationship with the sea, so perhaps their parents are working fishing vessels, perhaps they go to the beach in the summer and they cuddle about in the rock pools, you can bring this into your lessons and you can use this to engage with them about science and really get a spark in there as well. So it's a fantastic tool to be using. So if you want to find out more about the science capital, at the end of my presentation, there's a link so you can go up and read out and find out a little bit more about this. I talked about these fishing communities here. We head on, we'll see that fishing is another important ecosystem service that we get. So in 2019, this is the latest values that I could find, over £500 million was made in our economy through fishing. So you can see some of the species here that are particularly important to us. And mackerel was by far the most valuable species in there. So that came in at about £158 million worth, so absolutely massive. Now, fishing sustainably is actually quite difficult. So different types of fishing impacts our seas and the animals in them in different ways. That's why I have rules and regulations around this, from the areas that we're allowed to fish in, to when we can fish in these areas, and how we fish these creatures as well. So many of these rules are to reduce what we call bycatch. So that's the capture of fish that we don't actually want, or fish that can't be sold due to various rules and regulations. So there's a lot of scientists working in the marine sector to reduce this amount of bycatch that we have through a whole load of innovations, from adding lights to fishing gear to changing the mesh size of the nets that we use, only fishing in particular times. And there's even apps that we can use where skippers can share information about where to find the best catch and where they're getting a lot of this bycatch. They know to stay away from these particular areas. Now, in order to protect our fish, we also have these areas called MPAs, that's Marine Protected Areas. Currently in Scotland, we have about 231 of our areas, or marine protected areas. That's about 37% of our seas. So that's actually an incredibly large number. It's fantastic. And I want to tell you a little bit of a case study, a little bit of a story about one particular species. That's the flapper skate. They're absolutely fantastic creatures, and actually really quite large as well. Now, little is known about these species. In fact, up to a few years ago, we didn't know they existed. We had them confused. We thought the common skate and the flapper skate were one species. And unfortunately, once we distinguished and separated out these species, we found that the flapper skates were actually in a bit of trouble. They're actually critically endangered. Now, I was saying that we don't know much about them. What we do know is we found on the west coast, so in the inner Sound of Skye, they have a nursery bed. This is a fantastic find. So we instantly jumped into action. We put in an emergency marine protected area for these. And what we found was that these eggs can take up to 18 months to hatch. That's a spectacularly long time. So these are slow growing animals. So by instantly jumping in and protecting these areas, we're allowing the population to grow and expand without threat of fishing, so dredging coming in, ripping up these eggs, or any other activity that might cause harm to this population. Now, I want to introduce you to a concept just now. It's called the tragedy of the commons. It was first proposed way back when in 1830. It's a really simple way to think about fishing. So we have one connected global ocean. I know we break them into separate parts, but we have fish that travel right around the world in these mass migrations. So as much as it would be helpful for us to have just one dedicated species in our waters that doesn't leave, we have to work internationally with other countries to ensure that we're protecting these populations as best as we can. That's why quotas and these other rules that we talked about are quite important. So the tragedy of the commons refers to overexploitation of a common resource, so your fish here, to maximize the profits, and that leads to the eventual collapse of your populations and the subsequent fisheries that depend on these populations. So that's a bit of a complicated explanation there. I'm going to break it down so it's a lot simpler for you all to grasp there. And we're going to have a look at an example of this in Scottish waters. So this is the scythe, although you might know it more commonly as the pollock. So these are fabulous species. They're absolutely massive when you see them up close. And we had a booming fisheries based in the Firth of Clyde around these way back when in the 1960s. So you can see in front of you here, there's a little graph or a little chart here. This is called a boom-bust cycle. So if you look at the very start of the chart here, if you look at the green, we've got plenty of stock here. So we've got plenty of fish swimming about, lots for us to catch. And it's quite easy for us to catch it because it's just there. There's so much of it. So there's very little effort needed. Now demand's starting to grow. You can see that catch, that red line, is starting to go up there. And as this increases, we're catching more and more of this fish as their populations, as we would expect, are starting to go down. They're starting to decline. And as this does this, it's starting to get that little bit harder to catch all this fish. So there's less fish, so we have to work just that little bit harder to catch them all. Now, where catch is the same as the stock, so where we're catching as much fish as there is, what we have is a fully exploited population here. any more than this and we hit the tipping point. And unfortunately, that's what happened way back when. So in 1973, we were catching over 7,000 tons of this fish, completely unsustainable. And so as you'd expect, as you can see in the graph here, we had a population crash. It plummeted. Unfortunately, we carried on fishing. We never quite realized this until it was too late. And eventually fish dried up, disappeared. Of course, so did fisheries. So the effort became too much. As you can see here, the effort, it cost more to actually go out and look for these fish than we're actually making or profiting from the fish that we're catching. So the fisheries collapsed there. And as it did, stopped fishing for these creatures. And you can see at the very end, this population very gently starts to increase again. So it's a cycle here, this boom-bust cycle. And we can actually turn this into a game. So I'm going to show you an example of this. We'll quickly go through the rules and we can have a quick game here. So it's a great way to demonstrate to your students how fishing is this balancing act between supporting the livelihoods and protecting fish populations. It's quite a highly adaptable game, so it can be shortened or extended to fit the needs of your students. You can also change up the scenarios as well, so you can look at how climate change or introducing an MPA might affect these populations as well. So you'll see what I mean in a second. So all you need to do is split your students into small groups. Each of them are going to have a pond, so you can use a piece of paper for this. It's up to you how you want to do this, or even a bowl. You'll see what I mean again in a second. Each student has a different color, so that's going to be a different fish. And each day, so each turn here, your students are going to remove or fish out between 1 and 3 fish. So they have to sustain themselves. You have to get at least 1 fish. And they're bound to these quotas, so they can only take a maximum of 3 fish. That's how much their fishing vessels can take, let's say, part of the story that we're building around here. So you can see the instructions here, but I think it's going to be a lot easier if we just run through the game quickly, and you'll see what I mean. So look at day 1 here. We start off, we've got a beautiful, healthy ocean. We have 6 of our different fish here. So 6 red fish, 6 purple, 6 green. So this can be 6,000 tons, whatever you want to call it here. Now, we're fishing some out. So we're taking 1 purple, 2 red, and 3 green. And this is what we're left with. Now, at the end of each day, after we fish them out, the fish reproduce. For every pair of 1 color, we get 1 baby fish to replace what we took out. So you can see here, we only took out 1 purple. So we've got 2 pairs left over that we can bring together to produce a baby. So on the second day, you'll see that we have, what is that? 1, 2, 3, 4, 5, 6 fish again in the purple there. Now, if we run through the scenarios again, fishing out 1, 2, and 3 respectively, you'll see what's happening to our populations there. So purple is growing, it's expanding because we're fishing sustainably here. With the green, we're not fishing sustainably, and these populations are starting to decline. So we can start talking with our students, what do we think is going to happen here in the future? Now, as we continue on, we have our pairs, we're bringing in the babies. Fortunately, we've not got enough pairs left with these green fish. They're not reproducing, they're not getting any more. So as we run through this scenario, we then lose our green population. But you can see that the purple is doing fantastically well. It is thriving. And of course, if we run through this for a full week, a full scenario, you'll see that we've fished out our red completely, and we have a massive amount of purples left. So this is a really easy game to play. You can break kids into groups. You can use marshmallows, you can use Skittles, you can use different sweets if you want to. Color counters, you can have them cut out bits of paper if you want to do it quickly and easily there as well. You can change the duration of your game as well to suit your students' needs. So perhaps if they can't quite focus for that long, you can make that a little bit shorter as well. So that's a really easy, great way to talk about this tragedy of the commons, this overexploitation of fishing, and looking at how we balance our fishing needs. If we move on now to our next service, we're looking at the future of fishing and how we can change this. So aquaculture is an incredibly important part of our economy just now, and it's needing to be updated a little bit, and we are working in the right direction towards this. So there's a couple of novel techniques that we're looking at just now. So first of all is looking at, can we farm new types of fish? So just now, what we're doing is we're harvesting carnivores, these big fish, so think of salmons. salmon there. Now, these take a lot of energy to feed, to grow them up to a size that we can actually eat them, that we can use them. And that uses a lot of energy. So what scientists are proposing is that we bring it down the food chain a bit. We start looking at, can we eat these lower level fish, these herbivorous fish that don't need as much energy to raise and to cultivate. As well as that, we're also looking at introducing different fish feeds as well. So a lot of scientists are now looking at using insects, for instance, to give these carnivorous fish the energy that they need as well. So looking at creatures or looking at food sources that are a lot more sustainable, that use a little less water as well to create. Now, if we go on, we've got our bivalves as well. So bivalves are incredibly sustainable and a little bit delicious, if I do say so myself. So bivalves had quite a few different functions. But what's fantastic about them is that what we can do is we can grow them beneath our aquaculture sites. So on the seabed, that's where they grow. And they can take all the waste that comes down from these fish farms, these aquaculture sites. They can filter out this waste and they can use it for food themselves. So little maintenance, high reward. We're getting the systems of them as well. So they're very efficient, and at the same time, they're cleaning out the water. That's unfortunately an issue that we have just now around aquaculture sites. It's all this waste is falling down. It's creating something called eutrophication. So what we're doing is we're putting too many nutrients into the water around these sites, smothering everything else and creating dead zones. So by introducing these bivalves, we're cleaning out the water as well. And finally, we have seaweed. Seaweed is the new trendy thing. It can be used for so many different purposes, including biofuels. So replacing our current demand on fossil fuels, your oils and your gases there. It's also in a lot of products already that you might not already know about. So your toothpaste, ice cream, ketchup, so a whole load of different products that we already use this. And of course, it has a function in the water as well. As we grow these seaweeds, these create these kelp forests, and these are fantastic for increasing biodiversity. So you can have a whole load of different species of fish swimming in and around here, creating nurseries. It's absolutely incredible stuff, fast growing. Not only that, uses barely any land, and we don't need to use any fresh water for this as well. So absolutely fabulous stuff. Now I'm going to go on and talk a little bit about blue carbon here. So blue carbon is basically a term that we use to talk about storing carbon beneath the seas. And we can do this through looking at different sites, different habitats, and different ecosystems. In particular, I want to focus on a couple of them here. So first of all, you can see on your left, you've got Lophelia. Now, Nadia has explained to us about tropical coral reefs, stuff that we get in the shallower waters. What a lot of people don't know is that we actually have our own deep water coral reef systems. These are carnivorous corals. So these are an absolutely incredible asset in Scottish waters. And as they grow, what they're doing is they're taking in this carbon, they're using that for their growth, and they're locking it away deep down in the seabed. Not only that, as they grow, they create these structures, which, as Nadia was talking about, brings in all these different creatures, creates these incredible ecosystems. Now, in shallow waters around Scotland, what we have is the native European oyster. Unfortunately, this was fished out in about the mid-19th century as we introduced industrialized fishing. We're now working to reintroduce these. So there's quite a few restoration projects, what we're calling sea wilding. I love the pun. Conor did warn you there'll be more there. So this sea wilding is absolutely incredible. What we're doing, there's a pilot test up in Dornoch. They're reintroducing this European oyster. They're placing in these little babies, these little tiny little oysters, and they're creating a bed, a reef of these oysters. And just like the bivalves that we were talking before, what they're doing is they're drawing in all the nutrients, filtering out and cleaning the water. Just admit this person. So they're cleaning the water, they're creating these massive structures. So you're getting fish coming in, laying eggs, they're hiding from predators. You get a whole ecosystem built around this restoration. And of course, at one point, once we have enough of them, we can begin fishing them out again. So I've been told oysters are quite tasty. I don't quite believe it. Someone told me once that they taste like the sea, and I don't know why you'd want to try that, but you never know. We'll give it a bash in the future. And moving on from that, we're also rewilding seagrass. So seagrass is an incredible storer of blue carbon. So what we're doing is we're reintroducing entire meadows. And just like your Lophelia and your oysters, what you're doing is you're creating a brand new habitat. You're bringing in all these different creatures and restoring entire ecosystems at the same time, all whilst you're trapping this carbon as your seagrass grows, gets buried below sediments, and more grows on top. And lastly, we have our marl beds. So marl beds are a type of algae, a type of seaweed, but they're coralline, so they're a little bit like corals in that they've got quite a hard structure to them. And what we're doing is we're looking at these structures, growing them out, again, trapping carbon as they grow out there too. So again, a fantastic asset to our Scottish waters. Now, if I head on to our next one here. Now, our next ecosystem service, we have energy. So just now, there's a lot of talk you'll see in the news about oil and gas in Scotland. There's a Cambo oil field. Now, unfortunately, with oil and gas, of course, as we know, as you burn it, it releases all these greenhouse gases into the atmosphere, which is having negative consequences on our climate. So what Scotland is leading the way in is marine renewable energy, so these clean energy sources. And we have a whole load of places that we can place these around our waters. So let's start off with our wave power. So trials actually took place not long ago. So just last summer, the first tests of these were put into Scapa Flow up in Orkney. And Orkney is actually quite a popular site for these marine renewables, because not only do we have wave power up there, we have tidal power. So our first turbine was placed in 2008 up in the Pentland Firth. This is a fantastic site for this, because the Pentland Firth has some of the strongest tidal flows in the world. It is incredible. So an absolute powerhouse for us. And finally, of course, we have wind power. You will be seeing wind turbines being put up around the country. So you'll see quite a few of them offshore as well. They're a great place to pop them. However, there's studies going on just now looking at the impact of the cables that run from these wind turbines onto the mainland. So as the electricity passes through these cables, what we're doing is we're creating something called an electromagnetic field. So this magnetic field forming around the cables, and this can disorientate. It can have various effects on different sea creatures. We're not quite sure exactly the extent of the impact so far. There's a lot of research going on in this area just now. In particular, at the St. Abbs Marine Research Station, we have a dedicated marine research station that's looking into the effects on elasmobranchs, that's your sharks and your rays, as well as commercial fisheries, so your crabs and your lobsters as well. So it's incredibly interesting stuff going on there. Now, let's look at how this is going to affect our future climate. So by investing and building these renewable energies, what we can hopefully do is limit the impact of climate change, what's happening just now. So our climate at the moment is a lot warmer than it should be for the latitude that we're at. And that's because of what you can see in this little map in the bottom left of your screen. That's the Gulf Stream. So that heads up from the equator, up past the eastern side of America, across the Atlantic, and it reaches our west coast. And it means that Britain is actually a lot warmer than it should be. And as you can see behind it there, we actually have rainforests. That's right, we have these incredible locations that are, I don't want to say tropical, but they're a lot warmer and a lot milder. So they're absolutely fantastic environments there. Now, as we go into the future, we're talking about climate change here. We're expecting warmer and drier summers, as well as milder and wetter winters, unfortunately. So this can create a whole load of problems, including flash flooding, and that can lead to coastal erosion. So what we're going to be seeing in the future is a loss of land as these rains wash more and more cliff face down into our seas. And as well as that, we can expect marine heat waves. So these are isolated, localized areas of water that are going to be heating up a lot faster than the water around them, just sudden occurrences of this heat. And this can have massive detrimental impacts to the organisms living within these areas. Unfortunately, this is quite a new discovery, so we don't quite know enough about this yet to say what the long-term impacts of this are going to be. Now, I'd like to finish up just by telling you a little bit about Discovering the Deep. So this is our new project that Conor briefly mentioned at the very start there. So I'm the project officer for this. So I've been working closely with the science director here, getting a brand new gallery set up for you. So you can see a few shots of what we're hoping it to end up looking like here. We'll hopefully be open for about the 9th of April. And what we'll be telling you about is our history of marine exploration in Scotland, starting with the HMS Challenger. So HMS Challenger, captained by, or excuse me, not captained by, but we had the Chief Scientific Officer, Charles Wyville Thompson from Edinburgh. What they did was they travelled around the world 3.5 years, and they investigated our deep seas globally, bringing up all these incredible specimens, taking water temperature, looking at the salinity of the water, and creating this baseline that scientists still use today to look at how our climate is changing and how that's impacting our oceans. We'll be telling you the story about the hardships that they faced, they travel around, and the science that they conducted. And from there, you'll head in and you'll start exploring Scotland's deep seas, looking at these Lochilia reefs that I talked about before, and investigating some of the species that you'd found around there too. That's an incredibly exciting part of the gallery. Can't wait to see that one up and running. And you'll end by looking at a little bit of modern marine science as well, looking at techniques that researchers are using to investigate our oceans today, looking at the threats that our oceans are facing, and meeting the scientists themselves, finding out a little bit about what it is to work in marine science. And not only are we having this brand new gallery, but we also have a whole plethora of other activities that we're running around this as well. That includes brand new CLPL sessions. We'll also have new school workshops that looks from early years all the way up to senior level as well. And we're not just running these in Dynamic Earth, we'll also be taking these on the road. So as we head out to the different science festivals around Scotland, we're visiting a few different schools as well to run these sessions. As well as that, yeah, there's more. We'll also be running a couple of careers days in Dynamic Earth as well. So if you can bring your students along, come and visit that one too. So that is me. I'm going to head now over to Katrina, who's going to do a few demos for us. So thank you very much, everyone. And I hope you enjoy the rest of the session. Bye, folks.
Hello, everyone. I am going to share my part of the presentation. So like Blair said, I'm Katrina. I'm a Learning and Engagement Officer here. Prior to working here, though, I spent many years studying the ocean and have witnessed firsthand the impacts that it is facing. And Blair and Nadia have done an amazing job today of telling you all why the sea is so important and how we are connected to it. And that is why we are focusing on ocean literacy today. We want to make sure that you understand the ocean and how we can protect it. So first of all, you need to figure out what an ocean literate person is. So I've taken 3 things from their 7 forms there, and I've taken 3 of them here because Blair and Nadia have covered our first 2 here, which is understanding the importance of the ocean to humankind and talking about it in a meaningful way. And I think both of them have inspired us all and told us all about how we are actually connected to it. So I think sometimes we forget here in Scotland, we are an ocean community. We're surrounded by the sea. And so hopefully you can start to feel a bit more passion for that today. And the last one here is making informed and responsible decisions. And this is what we're going to look at next. So now we know why the seas are so important and some of the threats it's facing. We need to figure out how we can make these responsible decisions. And it's really important that you teach your kids about this too. They are the next generation and they need to make use of the ocean in a responsible and sustainable way. So we're going to focus on 2 things. I'm going to briefly go over the threats that our ocean face, remind you of some of the ones Nadia mentioned, and then add on a couple more. And then we're going to talk about resources to engage your class in these topics and how to get them inspired and passionate about saving the ocean as well. So first of all, we have our ocean threats. So Nadia spoke about sea level rise, and she also talked about ocean warming. And she did mention overfishing as well. I'm going to talk a little bit about destructive fishing. So Blair mentioned there's different kinds of fishing that goes on in Scotland, and one of those is bottom trawling. So if I click on this, there we go. So as you can see here, this picture below, I'm not sure why that box is there, apologies. This picture below is a bottom trawl. It's basically a giant net with really heavy doors that gets dragged along the seabed. And what happens is it catches loads of fish and it's really quick, but it catches absolutely everything else that it drags with it. So although it's efficient for the fishermen, it's destroying the ecosystems. So you can see the pictures here, the picture to the side here. This is a healthy coral reef here in Scotland, thriving. And this is what it looks like after a bottom trawl has gone through it. Now, in certain areas it is banned, but not across the whole of Scotland. And a lot of it happens in the deep sea. And we don't really know much about the deep sea. We know that there's these thriving coral communities and a lot of fish down there, especially fish that we eat for dinner, but we don't really know much about it. And a lot of these habitats are actually being destroyed before we can even go down and discover what's down there. So bottom trawling is a really harmful way of fishing. You can get alternatives, sustainable alternatives in the shops. If you look out for the Marine Conservation Society logo, it's a little blue fish on your fish, and that shows that it's been caught in a sustainable way. But this bottom trawling is a really big issue that we're having at the moment. So another one that I would like to mention briefly, Nadia touched on, is ocean acidification. So ocean, there's another triangle, apologies, I don't know why they're popping up. Ocean acidification is it not that cool? We are producing loads of carbon dioxide that's being pumped into our atmosphere. And unfortunately, the ocean is absorbing a lot of this. So the ocean is bringing it in and in and in. And what's happening is the water is actually becoming acidic. So it takes that carbon dioxide and turns it into carbonic acid. Now, the reason this is a problem is because although we can't tell that it's becoming acidic, those slight changes to pH affect creatures like coral reefs. And as Nadia showed us, they're really important. It also affects things like oysters as well, which we know are really important here in Scotland. So those tiny changes in pH are having massive impacts. These kind of animals use carbon to build calcium, to build their skeletons. And so they're having trouble and they can't actually survive. So you can see pictures here from our healthy coral reefs. Got a really giant fish there. And then you can see the pictures below are from reefs that have been affected by acidification. And you can see that they are dying. This reef here is pretty much all dead coral. And this means it can't support an ecosystem. So this is really bad as well. And the last one I'd like to touch on is plastic pollution. So unless you've been living under a rock, you know that plastic is bad and it is absolutely everywhere. So we have it on the most remote beaches. It's in Antarctica. It's even at the deepest part of our ocean down in the Mariana Trench. It has completely covered our planet. And every single piece of plastic that has ever been made is still on our planet as well. So it's really important that we try and stop this. Now, obviously, it's really important to recycle, but it is also important to limit your plastic use as well. So looking at things like replacing plastic bottles with recyclable ones or reusable ones, and trying to avoid how much plastic you use. And then if you do use plastic, making sure you recycle it. But we'll swing back to some other ways that you can deal with plastic as well. So you can see here that we've talked about 5 different threats throughout this session, and that's a lot to take in, and that's a lot to try and figure out how to teach your kids, how to inspire them to help fight these threats. So what we're going to do is it would take hours and days and years if we talked about all the different threats and how to teach them, but we are going to look at some resources to engage your class. So let's start off with yourselves. You've taken the first step, you're here today, and that's amazing. We also have some online stuff as well that we can help you out with. And we will be doing more online things as well. So if I start to share my windows here, we have an amazing resource called Dynamic Earth Online. Perfect. Can you see it if I switch tabs? Perfect. Okay, so we have our For Educators page here. So you can access this. It's just Dynamic Earth Online. Hopefully this is what brought you to our CLPL course. But we also have an online one. And then we also have some learning pathways. So you can see here we have more than just ocean stuff as well. But as we're talking about oceans today, we'll focus on that. Now, our learning pathways are really great way to kind of structure a lesson plan. So they provide videos, resources to read, and activities. So you can see here, we've got watching a video, you've got things to do, making your own hydrothermal vent on this one, things to read, and then more activities. And so you just work through these as you would through a lesson plan, but we have it all laid out for you. And the activities are really fun as well. There's some bioluminescence in there, which will definitely get your class excited. So these are more formal, structured ways that you can help improve your learning. But we also have some less formal, less structured activities that you can do with your class to help out and that you can try yourself. So we have lots of fact sheets on there if you want to just have a read about humpback whales. And a lot of these come with an activity, or we have quite a lot of crafts on here as well if you have any younger kids. So this one is making your own whale. Now, a lot of the stuff on Dynamic Earth is aimed at people all over. So we don't expect much. A lot of it is from household items or things you can buy on the internet really easily. These aren't super scientific experiments, and they're not too overwhelming. They're supposed to be there to be accessible for people like you. We also have lots of experiments on here, like hydrothermal vent making. This one is one of my favorites. So it gives you a little bit of background so you know what you're doing, and then it gives you all of your kit list and exactly what you need to do. So this one, they make a little hydrothermal vent, which is lots of fun. And then we also have some other kinds of activities like designing your own remote operated vehicle. And again, we get a little bit of background science, and then it gives you what you need to do here. So you can see an example of some other ones. So all of this is super accessible. It is just on our Oceans tab like this. And you can just click on whatever you like along here. Now we also have some really good profiles on here from experts. So Ruth Gates here, who I worked with in Hawaii, she was an amazing woman, really inspiring. And she's actually working on the supercorals that, well, she was, unfortunately, she's passed away. She was working on the supercorals that Nadia was talking about, and her lab is dedicated to trying to work that out. And then we have Ayana Elizabeth Johnson here as well. So we try to do expert profiles from lots of different ocean topics from people from all different backgrounds. So this is also a really good way to teach your kids all about the different topics in ocean that they can go into, and that anyone can be a scientist in STEM. So it's really important to promote that. And just looking through these profiles, you can see they don't look like scientists, but these two women are making a massive difference. So we have loads of online resources for you here, but as many of you are teachers, you'll probably want some hands-on activities to get those kids engaged. And we do lots of in-person workshops here, and so I'm going to show you some of the stuff that we do here. Again, this is the most accessible ones. Obviously, as a science centre, we've access to lots of really cool, quirky things, but I've tried to pick out a few that you could do in your classroom without having to buy too much. Now, I would be here for hours if I went through all of them, so I've just selected a couple here based on a couple of those threats that we talked about and some general ocean knowledge as well. So our first one we have here is our ocean knowledge. So this is a really good one. We use this for loads of stuff. This is our Atlas Reef mat. So as you can see, there's lots of different animals and creatures on here. And the idea is that you can print this off in any size, depending on what you have available, or you can put it up on a big screen if you like. So you can get kids to work in groups or individually or as a whole class. And if you print out these survey sheets to go with it, the kids have to try and find all the animals on the survey sheet there. So it's a really simple idea. We have it printed on a massive mat and just get the kids on the floor to have a little look around and see what they can find. And it's really simple. All you have to do is Google Atlas Reef Survey Mat, and that will give you the PDFs to print off. So this is a really simple, very easy one to print off and get your kids engaged with what actually lives down there in our oceans. And so this is a really fun one. We also have one to do with unsustainable fishing. So I mentioned those bottom trawlers earlier. We have quite a fun, engaging way. Talking about bottom trawling probably isn't the funnest thing. It's quite upsetting to think that the whole reef is covered up. So you get your kids up, get them going, and have a little go at this. So we've got a video to show you how it works.
So we've got this lovely ecosystem with all these different animals and corals. If you don't have a hat on, stand up as well. We need everyone stood up for this bit. And we're going to have you right in the middle. Thank you so much. Right in the middle. Perfect. So we've got our coral reef. That is where you all live, and you're all going to live in amongst this lovely Lophelia pertusa. But unfortunately, there is a danger to our coral reefs, and it is called bottom trawling. Does anyone know what bottom trawling is?
What do you think? It's where people catch fish.
Get along the reef to catch the fish, and that's not very good for the fish, and it's definitely not very good for the coral. So what we're going to do is you're all going to move around. We're not move around, and if you are something that can move, I want you to swim. But what about the coral? Can the coral move? So what are you going to have to do?
You have to save it.
Stand still. You need to save the coral. So we're going to bring the bottom trawling net way over the reef, and if it touches you, I want you to sit down, okay? Ready? Remember, nice and slowly. Oh, we've caught you as well. Oh no. Lovely. So who was caught by our bottom trawling net? Put your hands up. So we caught a couple of fish and our coral as well. So even the fish that got... You have nowhere to live now because we caught the coral. So that's not very good, is it? So I need everyone to come back round for me.
So you can see there now, if you don't have access to a fishing net, that's absolutely fine. You can use a sheet or something else. But the idea is that the coral can't move. And so you catch it, and not only does the coral die, but then also there's no homes for the fish. So it's really simple, fun way to get your kids up and active and show them that coral is really, really susceptible to this. Okay, I'm going to stop sharing my screen now, and I'm going to change to a different window again. Here we go. Can you see my screen? Awesome. Okay, so we're going to talk a little bit more about fishing. If you have older kids or you don't have the space for your fishing game and you have access to laptops, we have this tricky trawling game. Now, this is produced by London Zoo, and it is really fun, very frustrating game. So the idea is you go fishing. So if I just put this in here. So it brings you up, it gives you the whole thing. And it's really simple. So you just click on your fishing boat to go fishing. You try and catch as many fish. You can see I lower my net to try and catch the fish. But if I catch anything, full skate, sharp, and move. As you can see, I'm already on -34. I'm not doing a very good job, but I did it with the shark. Okay, let's see if I can catch these little shrimp. There you go. So you can see that it's really difficult, and you end up in minus points most of the time, but it's a really fun game for kids to do. It's very difficult and frustrating, but it's quite a nice one to show them the effects of bottom trawling that as well. I'm going to cut my losses because I'm about to catch a shark. Okay, if I escape, I should be able to get rid of that. And I get back. So that one there was called the Tricky Trawler game, and it's from the London Zoo, so ZSL Tricky Trawler. If you Google that, you can pop up with the game, and it's a really fun one to play with your class if you have access to laptops or tablets, if they're a bit more engaged rather than getting up and playing. So you have two different options to teach them about bottom trawling there. Okay, so we are going to move on to some other things now. We're going to be talking about plastic pollution. So it sounds crazy, but kids love litter picks. So if you do have the stuff to do a litter pick, go out and get your kids to go out and do it. We do it a lot with kids here. We even do it at our summer club and our kids club, and they absolutely love it. We get them to only about 15-20 minutes just around the block, and then they pour all of their rubbish onto a tarp, and we sort it into recyclable and non-recyclable and different materials as well. And we talk about what we could use or what might not need to be there. So if you see plastic bottles, we could be like, well, we don't need to use this bottle. And so don't underestimate a litter pick. It is really good. Now, if you don't have access to a litter pick, we have another really fun game that teaches kids about how plastic never really breaks down. So all you need for the rubbish game is, thank you, Lauren, some different kinds of rubbish. Now, you need a collection of natural and plastic. So we have a rubber boot, We also have a woolen sock. And then we also have cardboard in our games. So you can see we've got 3 natural products, all that break down differently. So our cardboard breaks down quite quickly, our sock not far after that, and then our rubber welly takes about 100 years. So it takes longer, but it does break down. So the idea is that natural materials will break down. But then you throw in a collection of plastic as well. So for us, we've got a little bit of wrappers and some bubble wrap here. And then we also have things like plastic bottles as well. So you don't have to use the exact rubbish. You can have different kinds, but we do have an online resource called The Rubbish Game, which will tell you the exact breakdown times if you did want to use the same kinds of rubbish as we do. But we throw in these plastic things, and the idea is that the kids have to figure out how long each of them takes to break down. So they may put a timeline down starting from 0 to 100 years. And the kids have to place on that timeline where they think this will go. Now, some of them catch on and they're like, we know plastic never breaks down, and so they don't put it on. But sometimes they do think that sometimes it does, because plastic bottles do break down. They just don't disappear. So the idea is to show them this may become something like a microplastic, but it's never actually going to leave our planet. So a rubber welly that we have here will eventually disappear, but our plastic bottle won't. So it's a really simple game to kind of highlight the fact that every single piece of plastic on this planet is still here. And I think that fact is just mind-blowing. So this is a really simple game to do. And you can just collect household objects. You can do it with a litter pick if you want to separate your litter out as well. But for those that don't have access, or you just want a cleaner way of doing it, then we just have rubbish like this in a bag, and we just put the timeline out. We've also attached a little bit of information to each one. If you have younger kids to help you along, you can see that with the light. Really simple things like breaks into tiny pieces made of plastic, or from the boot made from natural materials. So depending on your age group, you can put more complicated items in or give them less information. And that's just a really simple game to let them know how to break things down. So that one's called our Rubbish Game, and you can find it on Dynamic Earth online as well. And then we also have a craft relating to plastic as well. Now, recycle is really important, like I said, but there is some plastic that isn't recyclable. And so a good way to deal with this is making eco bricks. So this is quite a good craft to do if you have younger kids as well. And it's teaching them that if we can't recycle stuff, then we should repurpose it. And countries that this is quite popular in are countries that don't have recycling systems like we do either. And so it's a really good way of kind of recycling in your own way. So we're repurposing stuff. And it's really simple. You just get big plastic bottles and then plastic that isn't recyclable. So things like wrappers, pasta packets. Just get your kids to collect some stuff at home and bring it in. And you put it in the top and you get a big stick, which I don't have with me, and you press it down. And it just needs to be packed really, really tight. Tight to the point that if you go like this, you can see that's really hard. Now, what they do with these eco bricks is they line them all up with pieces of mud or some sort of clay or anything, and then they stick them together, and they can actually make like walls and seats and tables out of them. So you could make your own little eco brick chair or something, a little stool. So it's a really fun craft. It keeps them nice and busy. And it's a really good way of teaching that not all plastic is recyclable. So recycling isn't always the answer. Sometimes we have to repurpose as well. So this is quite a fun one. And again, don't underestimate the eco brick. We do it at Summer Club and they will spend hours trying to fill these up. Okay then, so we're going to move on to our last topic, which is ocean acidification. So Nadia briefly touched on it. And so did I. And this is when all that carbon dioxide is absorbed by our ocean. Now for this one, you're going to need something called bromothymol blue. You can see it just here in the jar. Now I've added a little bit of this and some water. You can buy this online. It's really cheap. And you only use a tiny amount as well, so it lasts a really long time. It will need to be locked away in your kosh cupboard though, because you don't want anyone drinking this stuff. Now all you have to do, this is a really fun one, is you just blow into it like this. They should change colour. Okay, you can already see that it's starting to go more yellowy. Yeah, awesome. So this is my carbon dioxide that's coming out of my mouth being absorbed by the water here. And this is what's happening in our ocean. So if I do that, so you can really see the light on it there. So what happens if it will go from a kind of dark blue greeny color to this yellow color here? And that is the water absorbing our carbon dioxide. It's becoming more acidic. And that is basically ocean acidification in a jar. So it's a really easy one to show them what's actually happening without having to talk through the chemical side of things. And it's just fun to blow bubbles as well. So that's always a really engaging one there. Now, last but not least, we have what is happening to our corals. So we've demonstrated what's happening to the ocean. It's becoming acidic. But what does that mean for animals? So corals and other animals like oysters and things, they use their skeleton for calcium carbonate. So this here is a piece of chalk. I'm sure you all have them in your school. If not, they're really easy to buy again. And this is a type of calcium carbonate. Now, it's not a coral, and it is slightly different chemically, but the idea is that it's made from the same substances. And so it can be used as a cheap alternative. And here I have a glass of vinegar. Again, the ocean is not like vinegar, but we want this to work quickly. And so this is going to represent our acidic ocean. Yes, we can send all the presentations over to you if you wish. So what you're going to do is you want to pop your chalk into your acid, give it a little bit of a shake. And I don't know if the light's going to hurt you here if I do this. There we go. Now, can you see it start to fizz there? Yeah. Here we go. So you can already see that there's bits of blue coming in the water there. So this is our chalk that's starting to dissolve in our acid. So you can see here that the chalk is not doing very well. Now, this would happen to coral over loads and loads and loads and loads of years. And it also means that they struggle to build their skeleton, but this is kind of a sped up version of what would happen there. So you can see, there you go, you can really see it there, that it's starting to disintegrate. So this again is a really cheap, this is just cheap vinegar and some chalk in a jar, and it shows ocean acidification. So we've got some practical things that you can do there. We've got some experiments, and then we've also got some online stuff, all of which you can adjust for your ages and what you have. So hopefully you'll be able to use some of those in the future in your classrooms. And yeah, we'll be sending these presentations out, and I can write the details down of what we've shown you today, and the names of some of the stuff that I've used. But otherwise, I hope you've had a great time, and I'm going to pass over to Conor now, who's going to wrap this up. Thank you so much.
Oh, thank you so much, Katrina, and thank you so much to all of you for joining us this afternoon. We hope you've enjoyed our CLPL session. Thank you very much for joining us, and thank you once again to the Scottish Power Foundation for supporting us to deliver these sessions. We really look forward to welcoming you to Dynamic Earth in future, either in person, either at a science festival, or online through Dynamic Earth Online. And we look forward to, just seeing you in the future and our new exhibition when it opens in Easter as well. Before we go, we will send you an evaluation via email, probably tomorrow morning, that asks you a few questions about the session today. There'll also be the opportunity for you to give us a little bit of feed forward into our new school workshops and some more insights to our new gallery as well. So keep an eye out for that, and we'd be really grateful for your time in filling that out and telling us what you thought of the session today. But otherwise, thank you all so much for joining us. Thank you to Nadia, thank you to Blair, and thank you to Katrina. And we look forward to seeing you all soon. Take care. Bye-bye for now.